Hi, everybody. I know a lot of you and seen you over the years. This is a little bit of a different feel here in Bangalore this year. It's getting a lot bigger, right? Year over year. I remember when these first started, even the PG days back in Pune and other things. It's exciting seeing this grow. The other difference I've seen this year, we've seen a lot of AI talks, right, which is kind of normal. But this kind of seems like the year of migrations, right? Looking around, seeing all the other talks and all the vendors, it's like everybody's migrating now. I've been doing migrations a long time. When I submitted this talk, I thought it might be the only one, but no, there's a whole bunch of them. So what I want to talk about is just a number of mistakes that I've seen over the years that people make, and trying to give you a heads up before you make them. So this way you don't have to deal with them when they're out in production. Just so I get an understanding, how many people are actively migrating into Postgres right now? How many are thinking about it? Cool. And how many of you are people helping other people migrate, like consultants, companies doing that? Cool. Just get an understanding of it. So I've been doing migrations with Postgres 25 years. Kind of first how I got into it back in 2000. We had a consulting company that had to find other ways to get revenue out from customers, and everybody was running SQL Server and Oracle. And hey, here's this thing called Postgres that had no license fee that nobody ever heard of. But it ended up working, and then we started doing that more and more. But I did notice some patterns. The reason why people make these mistakes is because they're trying to go very fast and they haven't learned Postgres yet. They're experts at Oracle or SQL Server. They've been using it for years. So they rely on tools in order to get things done quickly. Right? And because it looks like Oracle and SQL Server from the application standpoint, they assume it works the same way. Right? So, this analogy that works in a lot of different things. So I've always had a gasoline-based car. I'm an American. I drive a big truck, big pickup truck, right? But it's always been with gasoline. But I got a new one a couple years ago. It was a diesel. Get better mileage or kilometerage here for the rest of the world. That's not in America. But I could drive further on a tank, better things. So I was like, cool, I get a diesel. For the most part, everything was the same. Sounded a little different. My mic's not, there we go. All right, so a couple weeks ago, I ran into something. I was visiting some family up in New Jersey where it got really cold. We had a blizzard. And I knew about this thing about diesel kind of having problems with low temperatures, but I never really realized it. So the temperature got down to -10. And all of a sudden, my truck wouldn't go anywhere because it started gelling up. So I made the assumption that it behaved a lot like my gasoline trucks, but I didn't do the proper maintenance on it, and I had a total system outage. I had to call a tow truck to go get me home because I didn't do the proper thing because I made the bad assumptions. It's a lot like what I see with people when they run into these sort of mistakes is they make the assumptions based on what they did on Oracle and SQL Server that it applies to the same in Postgres. So they take everything they learned and said, this is how it works in Oracle, this is how it works in SQL Server, and I want to do the exact same thing in Postgres. So I want to make Postgres look like those instead of learning the right way to do it and be able to adapt to it so this way your application ends up running really well there. And that really comes down to time and experience. But that's why these mistakes are usually made. And they happen throughout the part of the whole life cycle, a bunch of different ways. So these are typical migration projects. You're going to evaluate whether or not you could do it at all. Some applications you can't move to Postgres. It might be something that Oracle apps, Oracle Financials isn't going to run on Postgres. Right? Then you convert the code. That's usually a pretty fast part of the overall project. historically, it's been 25% or less of an overall migration project is actually migrating the code. The testing, performance tuning, and all the rest of this stuff is really where all the time is. All right, and then this mic keeps going out on us here. I'll talk loud too, so this way if the mic doesn't work. Then you finally get down until you move over into production. But some of these things you find after you go to production. But some of the things we find early, they're easy, they're nuisances. You kind of correct it quickly. One of the quickest things that people find is the differences with Postgres is the case folding. With Oracle, right, all the metadata for all the table names and column names all fold to uppercase. Postgres, it folds down to lowercase. So this is one of the areas where Postgres is not ANSI compliant, following the spec. Just about everything else it is, this is one place it's not. But when you're using the tools, what they typically do is pull over the case from the source system. So if it was capital in Oracle for the people table, it's going to pull it over to Postgres with the double quotes. So what that ends up happening is becoming very, very tedious, that every time you have to access the table name or column name is you have to double quote everything and put it in uppercase because the tool pulled it over. Usually developers start complaining about that because you're like, select star from users and it's not there even though you know it's there, right? So it usually gets really annoying really fast that people find this. But sometimes people just put up with it and then go to production with it, and then that's where real problems happen. Because 3 months later, you go add a column to the table, and you add this new column, and you forget to double quote it. Now, 10 of the columns are all have a double hit and upper quote, and the one that you just added now is on lowercase, and if you put the double quotes on there, you can't find that column. Right? So you have to end up remembering forever that you have to be consistent of doing that. So, it's just one of those things that it's just like, oh man, I should have done that when I first did it. When you first do it in the beginning of the project, it's no problem. It's easy to adjust. If you realize it later after you go to production, now it's a big project to go back and change it. Another thing you find quickly are nulls. Oracle treats an empty string as a null. So when you run a coalesce on it, right, it thinks it's a null. SQL Server and Postgres follow the ANSI standard, and a null is a null. An empty string is an empty string. They're different. Right? You usually find this with string concatenation. So if you create a table, you have a table in Oracle with first name, middle name, last name, you concatenate them together, right? And run that, you get the 10 famous people. All shows up. Usually you find it real quick when you try to do that same exact query in Postgres, you get nulls, because in Postgres, if you concatenate anything with a null, you get a null. Right? So usually you find that pretty quick. Right? And then you adjust, and now I have to go put coalesce around everything in order to be able to handle it the right way because your application depends on that. It's a little tip. Instead of doing all that, Postgres does have some built-in functions like concat.ws that'll do all that instead of trying to coalesce everything. If you're really doing concatenating everything, use some of the internal functions, even though that might be a little extra to do from the conversion, right? It ends up with an easier maintainable code in the long term. What's a little bit more subtle that people don't find like right away or how it handles with unique constraints. So in Oracle, you create a unique index on a table that has 2 columns, C1 and C2. I insert a row in there, right? Then another one where C2 is null, and I try to do that again, I get a unique key violation. Because Oracle, a null, empty string, is all the same thing. Postgres, we do the same thing, create that same unique index. We insert a row, we insert another one, and another one, it succeeds. Because in Postgres, a null does not equal null, right? They're not the same thing. So this way, your original index that had that unique index on there won't throw the same error. So you'll end up getting duplicate rows if you don't account for that. But Postgres, you could adjust that index by, instead of doing for that unique index, you use nulls not distinct. Now you could insert the row, and then finally we get the error that you'd expect. But what happens is all those migration tools that pull your indexes over, they pull over the same index definition and doesn't account for the fact that one of those columns are nullable. And if you need a unique thing with nullable columns on there, you need to be able to put that on when you're coming over from Oracle to get the same behavior. Otherwise, you're going to get duplicates in there when you're not expecting it. Usually a subtle thing you don't find in that sort of thing, you don't usually find in development. You end up being later, and it may be even late in production when you get these duplicate rows because there was extra nulls in there you didn't anticipate. But around some of this is just kind of a little tip, not necessarily a mistake, is just Postgres could do a lot of things that Oracle and SQL Server cannot. It has a lot of other capabilities to it. And what I've seen people do with migration projects is I want to do it exactly the same as in Oracle or SQL Server and do the exact same thing in Postgres. They think that's going to make the project go faster, of doing exactly the same thing in both sides. That's true for a lot of cases, but sometimes if you could use some of the Postgres capability, you could do it faster, the overall migration faster. Because if you're using some of Postgres' native capabilities, you could eliminate a large amount of work to pull over, right? So, but don't try to rewrite the whole thing to do it the Postgres way during the migration, but be selective and tactical about it where it makes sense. You know, for instance, you might want to decide to use PLv8 because it makes more sense for a specific stored procedure to write it in JavaScript. Or maybe you use PL-Perl because you have a lot of string processing or regular expressions, and that particular function is better in PL-Perl. And it's easier to kind of leverage that instead of trying to replicate the whole same thing in PGCL. It might end up being faster for you. Right? But there's other things too. So this one kind of came from an example from a customer a long time ago. They had writing software for observability and monitoring. So they were collecting a lot of IP address data, right? And they had it all stored in varchar 2, and they migrated it over as varchars in Postgres, and they had this giant Oracle package, a couple thousand lines long, in order to handle the IP addresses and subnets and all this other stuff. And they said, we need to go migrate this. And I told them to drop it and just delete the whole thing. They were like, why? I'm like, Postgres has an inet data type that stores IP addresses and data type and subnets in it. And all the stuff they did, they had simple operators. So this way, is this IP address contained in this subnet is just part of native Postgres. Saved them weeks of work in converting that stuff and testing it because Postgres just had native capabilities they didn't have to replicate in PGCL, right? So there's certain times that it just makes sense to be able to move some of that stuff over. So then we get another class of things that we find a little later during the testing phase, because during the development, it's less obvious, but they come up a little bit later. But before we get into that, every time I talk to somebody about migrating stuff, especially if they're a manager, they're insistent on setting things up of being a failback, right? I want to replicate to Postgres, and then I want to also replicate back to my source system in case anything goes wrong, right? They're super insistent on doing that, right? And they spend a whole bunch of time of creating this elaborate thing to be able to do bidirectional replication, so you could replicate from Oracle to Postgres and replicate back. In order to be able to do that, in case anything goes wrong, they want to be able to get back out again. That becomes a real problem. It's bidirectional replication. Even doing that between Oracle to Oracle or Postgres to Postgres is a really hard problem. When you're doing that across databases, it gets to be super hard. But there's some people just insist on doing that. Don't waste time trying to do that. You know, I know the managers and executives and everybody's going to want you to do that. Focus on what the problem is you're trying to solve. First of all is replicating back to that main source system. You really want to keep that pristine to be able to go back. But think about it as a problem of failing forward, right? Of replicating from Oracle to Postgres back to another Oracle database or SQL Server, right? So this way, you're not trying to have to do any sort of conflict resolution or any problems. That the original one that you shut down is still exactly the same, and then you go over there. But it really comes down to when are you actually going to use that failback? People think that they could fail back 6 months later. In my entire time, 20-something years of doing that, I've never seen anybody do that, ever. 95% of the time, where the problem happens, is during switchover. Like, they just abort the switchover because something's not right. Maybe they just turned it on, right? And they pull the cord and say, nope, we're not doing the switchover, and they go back. It happens most of the time. One time in 25 years, I saw somebody switch back a week later, right? And that was the longest. Usually they go to production, maybe it's an hour or two and they switch back. So having that fail forward thing kind of worked out for them. The reality is when you think about a migration project, when companies are doing migrations, they stop total development on that application and they put it on hold, and they have this whole big backlog of things that they want to do. So after the migration is done, they apply all the things that was pending, and then a month or two later, if you actually wanted to go back to Oracle, the code actually won't work on Oracle or SQL Server again. You have to do a full other migration back. So it ends up being not necessary, and you're spending a lot of testing time doing that. So think through what you're actually needing to do for that failback of how much you need to do. Yes, set up that fail forward just in case. It's a nice thing to have, right? You put the helmet on, put the seatbelt on, those sort of things. But you don't have to wrap yourself in bubble tape in order to be able to get everything there. It's like, reality is you're going to find out real quick. And if you're going to spend all that time setting this up, you're better served putting that time to do more testing to catch it before you go there in the first place. And once you're there, it's usually faster to fix the problem on Postgres than it is to try to go back anyway. So this is the most common mistake that I see people make, is around data types. And you usually don't find it until too late. The data types choice is super important. In Oracle, you usually you get varchar 2s, you get dates, you get numbers. That's basically all you get in Oracle. Sometimes you get some clobs and blobs, right? Or sometimes they get some spatial things, but most of the time it's those three. SQL Server has a few more. But Postgres, just when you install it, has 64 base types. And then you could install all these extensions to get a bunch more, right? The problem is people make assumptions because they don't understand, right? So people assume that a Postgres text thing is the same thing as an Oracle clob. They don't realize that a Postgres text is a varchar. It's the same thing, right? So they kind of treat it as this special thing of being text, and they do all this extra work around it, right? When in reality, like, you could have a varchar, you can make it 10 megabytes, right, if you wanted to. It's really the same thing. So you could insert that, a 10 megabyte string into a Postgres varchar, right, and run the same length function on it, and it just works. There's nothing special about it the way an Oracle clob is, right? It's basically like just a long varchar, right? But this is the biggest one. So Oracle has all these numbers. You use it for your primary keys. You use it for your storing your money and like all these different IDs. And it goes up to number 38, right? So all the tools convert it over to a numeric, because it kind of sounds like the same thing, right? The problem is, when you do that, a numeric can get much, much bigger than an Oracle number. It could actually store 131,000 digits. It is not the same thing as a number. Right? It's like a number 38, it's more confined. A numeric, storing things like a primary key in a numeric is the same thing as storing like an email address in an Oracle club. Right? It's just overkill. Right? It's why the tools all do this is because any Oracle number you could think of will fit in a numeric. It's going to mean that the tools are going to succeed every time. Right? So it does the most conservative thing. That doesn't really work from a performance standpoint. So say we have these two tables, T1 and T2, and we insert 1 million rows into T1, 10 million rows into T2, and then we join them. Right? Runs in 2.7 seconds, which pretty quick to return back 10 million rows. Now, if we did the same thing with big ints, that same 10 million rows, it runs in 1.9 seconds. When it really comes out to both of them seems pretty quick, but that's a 39% performance difference. So what I end up seeing a lot of times are people saying, I'm doing this performance test, and it's a lot slower than Oracle or SQL Server. And when you look at it, all their primary keys are numerics. Right? It's because, and they're giving up this almost 40% in performance every time you do a join. Right? Every time you're doing an index lookup on that, you're giving up that, because the numeric is such a big thing. Use numerics if you're storing money, financial data. That's what it was for, what it was originally written for. Right? Not for your primary keys. Problem of finding this at performance tuning time is now you've already converted all the tables, but you've also converted all your sort procedures and triggers and everything with numerics, and now you have to go back and touch everything and change them all to big ints and retouch every bit of code, sometimes into the application code, right? And to be able to send the integers instead of like the decimals the right way, right? So now all of a sudden you have to redo a bunch of work because you found it too late in the performance tuning section when it's too late to another thing. When if you just pick big ints for all your primary keys and foreign keys from the beginning, you don't give up that 40% performance. So indexing, all the tools take whatever there is on Oracle and SQL Server and does the exact same thing in Postgres. And you know, whenever I'm talking to people, they're like, well, I have all these indexes. They might talk about bitmap indexes or things that Postgres doesn't have, right? Or things like that, right? And there's equivalence there if it works out. But the reality is the Postgres optimizer and how it executes is different than those other engines. So maybe about 90%, 95% of your indexes, you take the same B trees, and that's the right thing to do. But for about 5 or 10% of your indexes, they're going to be different. It may be that you don't need them in Postgres, so you may drop some of them. And there may be other ones that you're going to add to Postgres that weren't there on Oracle or SQL Server because they behave differently. Right? Common one is something like this with a like query where people are trying to do poor man's full text search of doing a like with, you know, a leading wildcard and a trailing wildcard. Postgres lets you create an index on that. It's going to work, and it's going to use that index for those random wildcards with a GIN index. Right? Works really well. In other data, you wouldn't do that. You'd set up a full text search, and you didn't want to do that because that might be an extra license cost or all these other things, so you kind of do it the slower way, right? Postgres, now all of a sudden, you could use an index, and your queries get a lot faster. Another one is, see this commonly, is people use UUIDs all the time, right? And they create that B-tree index on there, which, this got a few million rows in this table, runs pretty quick in 106 microseconds, right? In order to walk the B tree, in order to get there, right, it has to touch 5 buffers in order to find the right leaf to get to find the right entry. Pretty quick. But Postgres, you could create a hash index on that same field. Right? That runs in 76 microseconds, 79 microseconds. And it's only touching 2 buffers in order to get there because the hash is different than the B tree. And for something like a UUID, that in order to create the hash on that, it ends up being really, really efficient in order to be able to look up something like that. Right? When most people, when they migrated over, they never think to use a hash index for something like that because we were using B trees before. But it can get even better, thinking back to our data types, right? If that event ID actually used the Postgres UUID data type and not a varchar, it runs in 67 microseconds. So the planning right from the beginning of what your data is, how you should be indexing it, leads directly to your performance later. So the biggest time I get pulled into customers was one of 2 ways. One is just before they're ready to go in production and they're not getting the performance they asked for. It's too slow compared to what their source was. And they think it's Postgres being slow. Reality is they made really bad choices with data types and indexes almost all the time, whenever that happened. If you think that it's an individual query is a lot slower, most of the time it's one of those 2 things. And the sooner you catch it in the beginning, the easier your whole migration project's going to be, because thinking that, remember, the beginning part of switching to code is only 25%. All that testing is about 50% of a migration project. If you spend just an extra couple days getting your data types right in the beginning, you now save weeks in the testing side in order to be able to get there faster. But the ones that get more frustrating for people after they migrated are the ones they find after production. These are a lot harder to find, right? So you have to kind of think about them ahead of time. Because I get pulled in to talk to some customers. Everything's been running great in Postgres for 3 months, 6 months. Now all of a sudden we're having problems. It usually ends up being a couple things that end up being the source of that problem. One of it is exceptions. People use exceptions in their stored procedures all the time, right? Some applications, every single function in stored procedure has an exception block in it. And every one of the tools are going to take exactly what was in Oracle or SQL Server and do the exact same thing in PGConf. Right? This one, the simple stored function in Oracle, get first name. We're going to look for the thing based off the last name. If it's not found, we're going to fire the when no data found exception, and we're going to return null. That same thing in Postgres looks almost identical, right? This is why people move from Oracle to Postgres all the time. If you look as I flip these together, right? It's almost the same code, other than the header and the footer there, right? But all the tools take that thing and say, oh, this is an easy one to convert, and just move it right over, right? It ends up being a problem by doing that. The reason is whenever there's an exception block inside of your PGCQL, Postgres uses save points under the covers to account for that. So like this little bit of pseudocode, when it runs, it creates a hidden save point, runs your query. If there's an exception, it's going to roll back to the save point. Otherwise, it's going to release that save point. It's a lot of mechanisms under the covers to be able to run a simple select query. So that has a lot of knock-on effects, but one of them is, take this for example. We have these two functions. One is add foo, where I'm inserting a row into the foo table. Right? And the other one is add foo, but at the end I have an exception block that when others raise. So just whatever error is there, just raise it up. The exception block is there. So now when I run these, so this first one here on the left, I'm getting the current transaction ID. I'm going to run it a million times, and then I'm going to get the next transaction ID. So when I'm just running add foo, it consumed 2 transaction IDs in doing those 3 statements. So really, that add foo function in that loop of a million really consumed 1 transaction ID. When I do that with the one with the exception block, now all of a sudden it consumed 1 million transaction IDs. So that ends up being a problem in Postgres when we have 4-byte transaction ID counter. So what you have to do, every 2 billion transactions, you have to vacuum freeze all your tables, which for anybody that sees auto vacuum consuming a bunch of resources where it's sitting there it's running an aggressive vacuum to prevent XID wraparound, you don't want to consume extra transaction IDs, right? There's other follow-on effects for some of these with multi-exec and SLRU when you have a lot of concurrency around all these save points causing other problems, but this is the most obvious one, that if you're using that exception block for something like that doesn't actually need it, you're consuming all those transaction IDs and you're running vacuum really for no reason at all. You just have to be able to go and scan everything in order to freeze all the pages. And what ends up getting called is customers say, I have this vacuuming problem. No, you have an exception problem. It's not a vacuuming problem. Vacuum's doing what it's supposed to, because if you don't vacuum within those 2 billion transaction IDs, Postgres shuts itself down. So it's preventing itself from shutting itself down and causing data corruption problems. Right? So when the tools pull that over, it's creating those inherent problems that once you get under load, because this is usually it's like when you're testing, you're not running it enough in order to see these problems. You get in production, then all of a sudden, Black Friday comes around and you have extra load and you're consuming all these transaction IDs, and vacuum kicks off right when you don't want it to kick off. But it has to in order to prevent transaction ID wraparound. Right? But the reality is most of those exceptions are not necessary. Right? So if we rewrote that get first name function where there's no exception block, and we run it, with get the first name for somebody with the last name of Jordan, returns Michael. Lowercase j returns null. Does the right thing. Postgres in this one does not fire a not found exception. Right? It's just going to return the null. Right? You don't need it there. Right? You could make Postgres behave like Oracle, like by doing the select into strict syntax in order to behave like that and fire that exception. But don't do that. You're firing exceptions for no reason at all. Right? Don't use the exception blocks when you need to. If there's something important inside that exception block that you need to handle, do it. Right? But there's nothing wrong with using them. But don't do it blindly on everything, because you end up with bigger problems later. Right? So another common one is somebody doing it as a pseudo merge. They're inserting it, waiting for the duplicate key error, and then they're doing the update. Don't do that. Use insert on conflict. Use the Postgres thing to do that. You don't need that exception handling, because that's just going to burn transaction IDs. And that insert is also going to create a dead tuple, which creates even more vacuuming problems. It's like when you're thinking about these migrations, you have to learn more about how Postgres works under the covers for some of these more subtle things that you bump into that you'd never notice during your testing period. You notice it when it's from production 6 months later. The other one for our SQL Server friends are temporary tables. In SQL Server Sybase world, people use temporary tables for everything. For Postgres, those temporary tables are not really temporary. It leaves around a bunch of stuff. Right? And Postgres only has local, not global, which adds to that sort of thing. So if we were going to create a temp table with just A and B columns, when we look at PG class, it wrote a row to PG class, your main catalog entry. There's a row in there that's, the persistence is temp, but there's a permanent row in there, at least for now. Right? The bigger one is you look at PG attribute, which has all your columns in it. It has A and B, but Postgres has a bunch of hidden columns on them that's on every table, right? So if you went select, xmin comma star, you're going to see that hidden xmin column, or table OID comma star, you're going to see this hidden table OID column, right? But every one of your tables are going to have those 6 hidden columns in there, along with your regular columns. So creating that temp table added 8 rows of PG attribute. Right? So say I created a silly little stored procedure that created a temp table and it commits on drop, right? Some people just create the temp tables and they drop their session and those temp tables get dropped, right? I've run it 1,000 times. When we look at the number of dead tuples in our catalogs in PG attribute, we created 19,000 dead tuples by running that stored procedure 1,000 times. This is something that years ago a customer migrated from SQL Server to Postgres, and everything they did used temp tables. And they didn't know this part of it. And they were wondering, why is my whole database slow for everything we do? Turned out their PG attribute table was 2 terabytes in size, with almost all dead rows. Because they were creating so many of them, they had to do a vacuum full on their catalogs in order to shrink it back down again. Right? So temp tables are okay in moderation. Right? They're fine. Right? But think through, do you actually need to use a temp table for everything? One of my colleagues at AWS, who worked on the Aurora team, was an ex-Sybase person, right? And his mind just thought about solving problems using temp tables. I'm going to load up this temp table, and I'll load up this other one, then I'll join them together, and I get the answer like that. And no matter what, he couldn't figure out a way to do it because his brain was fixed of that's how I write my stored procedures. He's like, Jim, can you help? Can you help me do it the Postgres way? I'm like, okay, and I wrote it as a CTE, right? Common table expression. Exact same thing of being able to do it basically as ad hoc temp tables. Each one of those CTEs is like materializes it, and then you join them at the end, right? It's just doing it so long, the SQL Server and Sybase way with the temp tables, it's hard to envision other ways of doing it. But all of a sudden, that took away all that potential bloat and did it as a single query. It didn't even need to be a stored procedure anymore, because it could just be an ad hoc query. You didn't need all that in order to be able to do the temp tables, right? So think through during your migrations. If using a temp table for a quarterly report, you run it once in a while, who cares? But if it's part of your main flow, every time, say, a user logs in, you're creating a temp table, you're going to end up with these bloating problems. So think through of really how much you're going to be using of it overall. Right. So kind of to wrap things up, these are not really mistakes. These are things that people are just making assumptions based off of Oracle and SQL Server, thinking Postgres runs the same way. And when they learn how Postgres is different, it's usually easy enough to make those changes. But because they're running under tight timelines to do the migration projects, they don't have the time to learn right in the beginning to not make these mistakes or figure out what the right assumption should be of the right way to migrate stuff over. Great. But the truth of the matter is a lot of times you do get a successful migration, even doing every one of these things. You can get to production doing all of these. It just ends up being more painful later of maintaining that. And then you you kind of think that, hey, Postgres doesn't run as fast, it's more troublesome. It's because you didn't get rid of some of those assumptions in the beginning in order to be able to get a better output at the end. But it does end up, if you know about these, you could kind of avoid them. They're usually easier to avoid when you know about them coming in, right? They're pretty simple. Hopefully some of these LLMs, we could find ways to teach the LLMs to do it the right way, not the way that everybody else has done it on the internet, and be able to avoid some of these things. I have seen trying to tell LLMs when I basically give them my presentation, right, and say, don't do these things, the LLMs do the right thing. So if you know about the different things to avoid and you tell the LLMs not to do them, right, it doesn't do them. Right? So there's ways to kind of get there, and hopefully as more people know about it, inherently that becomes more the migration process. But thank you.